When performing a transformation on a coordinate grid, we can use ordered pair rules to describe that transformation. Ordered pair rules. If your transformation is a translation, the translation rule looks like this. You start with x, you're going to add a certain amount to the x value, which we'll call h, and you're going to add a certain amount to the k value, which you'll call, or to the y value, which you'll call k. So this means that you would add h to the x coordinate, and you'd add y to the, and you'd add k to the y coordinate. Let's take a look at the example. If my ordered pair rule is x plus 2, y minus 3, it means I'm going to take each of these points, like this first one, which is the point -5, 0, and I'm going to add 2 to the x value. -5 plus 2 is -3. And then I'm going to subtract 3 from the y value. 0 minus 3 is -3. And this point, -5, 0, would be translated to -3, -3, which is right here. This is the vector that it is translated by. Now, I can keep going. I can list the rest of the points. This point would be -2, -2 in my pre-image. I can add 2 and subtract 3 to get my new point. Or I can just remember that a translation moves every single point from the pre-image the same direction and the same distance to get to the image. So if this was the vector, I could copy that vector and move it over. It goes down 1, 2, 3 over 1, 2. I can go down 1, 2, 3 over 2, put a point. I can go down 3, 1, 2, 3 over 2, put a point right there. And my new image after translation is here. So this is an ordered pair rule. I can rewrite that ordered pair rule as a vector. A vector describes the direction and distance that something would move on the coordinate plane. And we use these symbols to mean move the point 2 spaces to the right and down 3. So we can also define translations using a vector. If the ordered pair rule takes the point x, y, and maps it to x plus something, y plus something. This is also called a mapping rule. Let's figure out that mapping rule. It looks like the x value goes from 0 all the way over to 6, so that's going to be x plus 6. And the y value goes from -3 up to 2, so that's 5 in the positive direction. So if this is my ordered pair rule, or my mapping rule, my vector is 6, 5. Oftentimes you'll translate a shape, you'll pause, you'll translate the shape again, you'll pause, you'll translate it again, and then you have to figure out where did that shape end up after the 3 translations. So in this example, I'm going to apply the first transformation, which is to add 3 to every x value and subtract 2 from every y value. In other words, I'm going to use the vector 3, -2 to move every point 3 to the right and down 2. 3 to the right would take this point here, down 2 puts it there. Let's look at this point. 3 to the right puts it over here, down 2 puts it here. This one, 3 to the right, down 2 puts it there. And so this is my shape after the first translation. Let's look at the second translation. This says move the shape down, or to the left one and down one. So the left one and down one means this point goes left and down. This point goes left and down. This point goes left and down. If I want to find the total translation of these two, I'm finding what's called the composition. So what makes my original point go to this second image point? I have to move it over 2 to the right and down 1, 2, 3. 2 to the right and down 3 happens to be the sum of the two translations. 3 plus negative 1 is going to give me 2. Negative 2 plus negative 1 is going to give me negative 3. So the final result is 2 comma negative 3. This is just one big translation.